Hello guys, how are you today? So today I'll be explaining the math course practice of geometry section 5.1. Okay, so let us start with the first question. In lowest terms, the area of an equilateral triangle of side length 8 centimeters is equal to. An equilateral triangle, what do we know about an equilateral triangle? We know that all of its sides are equal. That means this is 8 centimeters, this is 8 centimeters, and this is also 8 centimeters. Now, another property that can be found in all equilateral triangles is that all of its angles are exactly 60 degrees. Alright, so now they need to find the area of an equilateral triangle with side length 8 centimeters in the nearest terms. So, very simply, to find the area of any triangle, whether it's a right triangle, not a right triangle, equilateral, isosceles, whatever, any triangle, to find its area, we are gonna do 1/2 times side times sine the angle in between them. This is for any triangle. This is to find the area of any triangle. So, very simply, if we apply this rule, it is going to become 1/2 times a side, which is 8, times another side, which is 8, times sine the angle in between them, which is 60 degrees. So on your calculator, if you put it, it is going to be 1/2 times 8 times 8 times sine 60. You will get an answer which is 16 radical 3 centimeter squared. So your answer is supposed to be 16 radical 3. We move on to part number 2, or question number 2. They said, refer to the figure below. Fill in the blanks with a whole number. In lowest terms, the area of the figure is equal to. They need us to find the area of a trapezoid. In this case, we are given what? That this side is parallel to this side, and when these two sides are parallel with each other, that means any line coming from this side is going to be equidistant. That means this has the same distance as this, so it is 6 centimeters. Now, very simply, you can do this in many ways. A way that I prefer to solve to find the area of the trapezoid is I divide it into two parts. I divide it into two triangles. This triangle over here with angle 60 in between the two sides, and this angle over here, as we know, this angle is supplementary, or these two angles are supplementary, meaning you add them, you will get 180. So very simply, to find this angle, it is 180 minus 60, which is 120 degrees. So now what we're gonna do, we're gonna say, okay, this is area 1 and area 2. We're gonna find the area of each triangle and add them to each other. This is personally how I would do it. So, area 1 is equal to 1/2 times side times sine the angle in between them. Area 2 is equal to 1/2 times side times sine the angle in between them. Okay? You are gonna add them. So on the calculator, you are gonna put 1/2 times 6 times 9 times sine 60. You are gonna get an answer which is 27 radical 3/2. And then for area 2, it's gonna be 1/2 times 5 times 6 times sine 120. And you are gonna get 15 radical 3/2. Add them to each other, and you are gonna get an answer which is 21 radical 3. So the answer over here is supposed to be 21 radical 3. We move on to question number 3. In lowest terms, they need the area of a regular hexagon. Pay attention, a regular hexagon whose apothem is 6 centimeter is equal to. Very simply, the area of any hexagon is 1/2 times the apothem times the perimeter. This is the case in a hexagon. Why? Okay, so only in a hexagon, a regular hexagon, pay attention, we can use this equation, which is 1/2 times the apothem times the perimeter. So let us just imagine this hexagon. I know it's not gonna look nice, it's just like a drawing to kind of understand what we are dealing with, okay? So the apothem is 6 centimeters. What is an apothem? The apothem is basically the height. Okay, so this is 6 centimeters. Okay, and then to find the area, we also need the perimeter. So we already found the apothem, which is 6, it is given. And now we need to find the perimeter. To find the perimeter, we have to add all sides together. But to do that, to be able to add all these sides together, we need to find the value of one side. Very simply, when dealing with a regular hexagon, it is divided into 6 equilateral triangles. So if you do it like this, you are dealing with a semi-equilateral triangle. So if you find this side over here, then you will be able to find this side over here because it is an equilateral triangle. Okay, so to find this side over here, there is a specific rule for it in a regular hexagon or in an equilateral triangle. In the equilateral triangle, to find the side or the hypotenuse, let's say the hypotenuse given the apothem, what we're gonna do is we are gonna take okay, so in the equilateral triangle, always the apothem is equal to what? It is equal to side times radical 3/2. So in this case, it is our job to find what? To find the side. So very simply, apothem, which is 6 centimeters, is equal to side times radical 3/2. Move it to the other side, you get that side is equal to 6 times 2 over radical 3. Okay? If you put 6 times 2 over radical 3 on the calculator, you are gonna get that the side is 4 radical 3. So, very simply, we just found the side to be 4 radical 3. So now, our equation will become 1/2 times the apothem, which is 6 times the perimeter. The perimeter is the addition of all sides, and since it's a regular hexagon, that means all sides are the same. And hexagon means 6 sides, so it's gonna be 6 times the value of one side, which is 4 radical 3. So on the calculator, if you put it 1/2 times 6 times 6 times 4 radical 3, you are gonna get an answer which is 72 radical 3. And very simply, our answer is 72 radical 3. We move on to question number 4. Question number 4 has 3 parts. So in the first part, they want us to find the area of BAE. Very simply, we can start dealing with similar triangles. Okay? This is a right triangle. So to find the value of DM, we are going to apply Pythagoras theorem. So it's going to be hypotenuse squared minus side squared. You are going to get that the answer is going to be 3. Okay? Now, these two angles are vertical angles. That means these two triangles are proportional triangles or similar triangles. Okay? So, if you find the area of this triangle, you would be able to find the area of this triangle knowing what? Knowing that the equation side 1 over side 2 is equal to constant. Area 1 over area 2 is equal to constant squared. That's it, very simply. Now, let us find the area. The area, very simply, it's 4 times 3 over 2. So it is 6. So our area 1 is gonna be 6. Okay, so side 1 over side 2 is equal to k. Then area 1, which we found to be 6 over area 2, is equal to k squared. Alright, now we can find the value of the sides. Very simply, what we could take is we could take the hypotenuse. We have hypotenuse being 15 and hypotenuse being 5. So since we started with this one on top, we are gonna put this one then on the bottom. So side 1 is gonna be 5, side 2 is gonna be 15, so 5 over 15 is equal to constant. Alright, then that means, so 6 over area 2 is equal to constant squared. If 5 over 15 is constant, that means 6 over area 2 is equal to 5 over 15 squared. Now what you're gonna do is cross multiplication. So you are gonna get 6 over area 2 is equal to 25 over 225. Cross multiply 25 area 2 is equal to 6 times 225. And then you are gonna get that 6 times 225 over 25. You will get that area 2 is equal to 54. So very simply, we found the value of area 2, or which is the value of area of triangle BAE, which is 54 centimeters. Now, what is the area of ABCD? To find the area of ABCD, very simply, we are given what? We are given a height. This over here is our height. Alright? And this over here is the base that it touches. And because they are, it's a parallelogram, they are parallel and equal, so this is also gonna be 15. So, the area of any parallelogram, I think you guys know, it is base times height. So it's gonna be 15 times 4, so it's gonna be 60 centimeters squared. So the area of ABCD is 60 centimeters squared. Now they need the area of the polygon EDCB. The area of all of this polygon, very simply, it's this area plus this area. So if this area was 54, it's gonna be then 54 plus 60, which if you put it on the calculator, you are gonna get it to be 114 centimeter squared. Okay, we move on to question number 5. Here again, they told us, what is the area of an equilateral triangle of side 12 centimeters? Again, equilateral triangle. All sides are equal, 12, 12, 12. All angles are 60. Okay? Now they need the area. So again, to find the area of any triangle, it is gonna be 1 over 2 times side times side times sine angle in between them. So 1 over 2 times 12 times 12 times sine 60. So if we put it on the calculator, you are gonna get an answer which is 63, not 63, oh my goodness, 36 radical 3. So our answer is gonna be 36 radical 3 centimeter squared. We move on to question number 6, which again is a similar question to question number 3, I believe, or not question number 3, question number 2. So question number 6, they told us they need us to find the area of this figure. Again, what do? We know these are parallel, so if they are parallel, this has to be equidistant to this, so this is also 8 centimeters. We cut them into 2 triangles. We have, this is 60, so this angle over here is going to be 180 minus 60 because they are supplementary. Okay, then you find the area of the 2 triangles and you add, it becomes 1 over 2 times 8 times 11 times sine 60, okay, plus 1 over 2 times 5 times 8 times sine 120. If we put it on the calculator, you are gonna get an answer which is equal to 32 radical 3. So very simply, in lowest terms, the area of this figure is 32 radical 3. We move on to question number 7. Again, in lowest terms, the area of a regular hexagon whose apothem is 12 centimeters is equal to a regular hexagon. Let us draw it again. It looks something like this. So 12 is the apothem. Remember, the apothem looks something like this. So it is forming an equilateral triangle. So always a regular hexagon forms an equilateral triangle. And to find the value of the side again, we know that apothem is equal to side radical 3 over 2. So side is equal to apothem times 2 over radical 3. Okay? So to find the value of the side, you are going to put on your calculator 12 times 2 over radical 3. And you got the value of the side to be 8 radical 3. Now, the area of any regular hexagon is 1 over 2. So again, the area of any regular hexagon is 1 over 2 times the apothem times the perimeter. So 1 over 2 times apothem, which is 12, times the perimeter, we know because it's a regular hexagon, all these sides are equal, so they're all 8 radical 3. So it's going to be times 6 times 8 radical 3. So if you put it on the calculator, 1 over 2 times 12 times 6 times 8 radical 3, you are going to get an answer in decimal. So your answer is going to be 498. One second, let me fix my 498.83 whatever. And then to get the answer which we need to put on the computer, as you can see, we have radical 3 over here. So whatever number is multiplied by radical 3 will give us this number. That means this number, if we divide it by radical 3, you are going to get the answer which we are supposed to put over here, which is 288. So it is 288 radical 3 centimeters. Now we move on to the last question, which is question number 8. Here part A is an easy version, but part B is a bit more complex. Now we will see why it is a bit more complex. The area of an equilateral triangle of side length 10 centimeters is equal to whatever. So the area of any equilateral triangle, remember 60, 60, 60, and then 10, 10, and 10. The area of any triangle is 1 over 2 times side times sine the angle in between them. So it's gonna be 1 over 2 times 10 times 10 times sine 60. So very simply, you are gonna get 25 radical 3 centimeters. So you just put 25 over here. Now find the area of a regular pentagon. Pentagon is 5 sides of side length 146 centimeters. Use tangent 36 degrees, approximately 0.73. Let us draw a regular pentagon. I know it's not going to be the best drawing, but it's what I can do. So a regular pentagon will look something like this. Almost like this, okay? It's not a good example, but just like imagine, it's a pentagon. So side length is 146 centimeters. Now, what we need to know is that a pentagon will form what? A pentagon will form 5 isosceles triangles. So with the center, it will form 5 isosceles triangles. Isosceles means these sides are the same. Okay? And now, to find the value of the interior angle or the single interior angle of a pentagon, what are we gonna do? We know that if we find the exterior angle over here, it will help us a lot. So let us find it. To find the exterior angle, it is 360 over the number of sides. So 5. So it's gonna be 360 over 5 because pentagon is 5 sides. You will get 72 degrees. So over here, this is 72 degrees. So what you need to know in pentagons, this exterior angle over here is the same as the interior angle over here. So this is also 72 degrees. Okay? And this leaves us with what? With this angle over here. Let me change the color. Let me take black. This angle over here to be what? To be 180 minus 72, which is 108 degrees. Now always remember, in the pentagons, and more specifically irregular pentagons, the sides are angle bisectors. So that means this angle, if it was before choose a different color. If it was before all of it 108, then the side will come, it will take this part, it will bisect it, so it will cut it in half. So 108 divided by 2, you will get that this angle over here is 54 degrees. Okay, so now with this information, what are we gonna do? We are gonna be using the properties of an isosceles triangle. In the isosceles triangle, the height, which is the apothem, always remember apothem equals height, it is equal to an angle bisector. So that means it will cut the 72 degrees into a half, which is then 36 degrees. Okay? So now we found in this semi-equilateral triangle that the angle is 36 degrees. Now, because it is an angle bisector, it's also going to be a segment bisector. So if this is 146, then this side is going to be half of 146, which is 73. Okay, so very simply, it is 73. Now we need to find the apothem. If we find the apothem, everything will become easier. To find the apothem, okay, so to find this triangle, let us take it as a side like this. Okay, we will take it outside like this, so it looks like this, yeah? We have that all of this is 72. We cut it in half, and now it is 36 degrees. We know this is 90 because it's a height, it's an angle bisector, and it's a side bisector, so we have this to be 73. Okay? And they need us to find the value of this side over here. Very simply, we will apply the SOHCAHTOA rule. So, you have an angle, you are given opposite side, and you need to find adjacent side. You will use tangent. They said use tangent 36 approximately 0.73. So, it's gonna be the opposite, which is 73, over adjacent is equal to 0.73. You will switch them now. So 73 over 0.73 is equal to adjacent. Adjacent is then equal to 100. So now we have the apothem, which is 100. And the apothem will be part of helping us in finding our area. So it will become 1 over 2 times what? Times the apothem, because the equation to find the height of any regular thing is 1 over 2 times the apothem times the perimeter. So 1 over 2 times the apothem, which is 100, times the perimeter, it is 5 sides, so it's gonna be 5 times the side of 1, which is 146, because it is a regular pentagon. So 1 over 2 times 100 times 5 times 146, you are then gonna get 36,500 centimeter squared. So that is it. Let's submit, and hopefully we don't have any mistakes. And thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed, and have a wonderful day.